This question says let P point xy be a point in the graph, y equals x squared minus x squared plus 4, which is that graph right here. So so this right here is that upside down U shape, right? It's a parabola upside down U shape. X is going between 0 and 2. Let PQRS be a rectangle with one side on the x-axis and two vertices on the graph. So this rectangle right here, which notice it hits the upside down parabola, right? It's fitting in there. We call it, it's inscribed, is how we say it, as shown in the picture. Find the x value for the rectangle with the greatest possible area. So in other words, we're saying like, hey, if you've got this upside down parabola thing and you want to put a rectangle, because there's different kinds of rectangles, right? You could put a rectangle like this, be a little wider, but it would be shorter. Would that be more area? Probably. How about if you go even further, even wider, but now, it's always got to hit the two upper sides have to hit that. So I'll just compare a few of them. So there's three of them, for example. Look at those three rectangles. They all, their tops are hitting the upside down parabola. You could do a really thin one where the tops hit up here. Like which of those, say, four rectangles do you think has the biggest area? Maybe that third one, you know? So there's different rectangles. They're all hitting the top of the parabola. Some are wider, some are more narrow, some are taller, right? The taller ones are more narrow and the wider ones are shorter. So which one's going to give you the maximum area? Well, to do that, so let's be clear, we're trying to find the greatest possible area. So we want to maximize the area of what? Of the rectangle, right? The rectangle, greatest possible area. So what's the formula for the area of the rectangle? Well, the area of the rectangle is length times width, right? You know that's one side times the other. You know what I mean? Like if you have a rectangle that is, let's say, there we go. It's 3 squares tall and 2 squares wide. You know there's 1, 2, 3, 4, 5, 6 squares in it, right? It's 2 times 3. It's one side times the other, right? It's length times width. One side times the other. That's how you find the area, the space in the middle of a rectangle. Okay, great. So what are the length and the width here? Well, here's the width. Here's the length. You could switch them. It doesn't matter which one you call length and width, whatever. Right? It's just one side and the other side, whatever you want to call them. So how do we know what those sides are? Well, here's what we know. We know this is the point XY right there that hits on the parabola, right? So what does that mean? Well, X is how far from the middle over this way. That's X. And Y is how far up. So then the width must be 2X and the length must be Y. Is that too quick? Well, you might say, why 2x? Well, because remember, whenever we do x, y coordinates, we start at the origin, we go over x, up y, there's the point x, y. So notice that x is only half the width. The width is two of those x's, isn't it? Whereas the y is the same as the height or length of the rectangle. So we go, okay, so then the area of the rectangle is length times width. The length is y, and the width is 2x. So you could just rewrite that 2xy. So the area is 2xy. The area of that rectangle, the area of this rectangle, didn't do that very well, is 2xy. Now, the problem is and we want to maximize that, right? We want to maximize the area. Now we must get this to only one letter. This formula here. We don't want two letters. We never want two letters in what we're trying to maximize or minimize. Well, how are we going to do that? We got to plug in for one of them. So, well, where can we plug in? Right here, right? Because if this point right here is on the parabola, then the xy coordinates must be satisfied by the parabola's equation, right? If you're on this parabola, then your y coordinate is negative your x coordinate squared plus 4. That's what it means to be on that parabola. All the points on this parabola satisfy the equation of that parabola. That's how graphs always work, right? If you're on the point of a graph, that means your XY coordinates make the equation true. So this point is the upper right-hand corner of the rectangle. It's also a point on the parabola. So the XY coordinates must satisfy that. So we can take this then and just plug in right there for Y. Oh. So then we go, oh, okay, maximize area equals 2x. And when it comes to Y, we'll go negative x squared plus 4. See what I did there? So this Y became that this is Y. And the formula was 2xy, 2xy. Y is negative x squared plus 4. So now we can clean that up a little bit. We want to maximize the area of that rectangle. I'm going to distribute. So that'll be minus 2x cubed plus 8x. All right. Now it's time to maximize. How do we maximize? We take the derivative. Take the derivative of that thing. All right, let's bring that 3 down. Get minus 6x squared plus 8, right? The 1 power comes down, subtract 1, it's gone. And then we always do what? Set it equal to 0. So I'm going to jump this guy to the other side, and we get 8 is positive. 6x squared divide by 6. We get x squared. I'm going to reduce that 4 thirds. Divided by 2 top and bottom there. All right, root it, root it. X is the square root of 4 thirds. Is that what they wanted from us? Yeah, and so we're going to hit the buttons on the calculator. Hopefully we'll get that same answer. For the Desmos, square root of 4 thirds, 1.1547. 1.1547. There we go. So what do we do again? We identify what we're trying to maximize. We're trying to maximize the area of the rectangle. The area of the rectangle is length times width, or width times length, whatever you want to call it. The width is 2x because x is from the middle over. So 2x is the width and the length is y. So it's 2x times y, or 2xy. But we have to make that one letter. The thing we're going to maximize, we always have to make one letter. So we use the equation because that points on the parabola. That xy points on the parabola. So plug in for y right here, minus x squared plus 4. Y is minus x squared plus 4. Y equals minus x squared plus 4. Plug it in, distribute, then we're ready to go. We got it one letter, we got it ready to go. How do you find the max? You take the derivative. Set it equal to 0, solve for x, and there we go.